Okay, class, we are going to do some graphing today. So you do need these lecture notes, so you should either have the copy that I gave you in class or you should print out the one on Moodle before we begin, because you do need these graphs because it is heavily intensive. So we are shifting, reflecting, stretching graphs. Okay, so we're going to talk about the parent functions, and then we are going to do all of our different types of shifts that we have. Okay, so these are the base functions, also known as the common or parent functions. So these are the different ones, and it has the key points marked. So for the line has 2 points. All of the other graphs that we're going to have are the 3 key points, and we're going to take our key points and shift them. And you can see these are all in scales of 1, so you can see what the key points are that we are going to graph. So when we graph any of them with the shifts and the stretches, we are using these key points. So this is a great slide to have handy. You are going to have to recognize the shapes and remember what the key points are for these 6 graphs that we will be doing with the shifts. Okay, so first we're going to start off with our horizontal and vertical shifts. So if you have a function and you have a number on the outside of it, that is going to be the shift up or down. So if we have our plus 6, we're going to shift it up 6. So it's going to shift the graph y equals the absolute value of x up 6, because it takes the base graph and shifts it up 6. Here we're going to shift the graph y equals x cubed down 4, because it's a minus 4. Now the horizontal shifts are the ones inside the function, like inside the square root or inside the parentheses for the squaring. And horizontal shifts always go in the opposite direction. So this shifts the base functions y equals square root of x. It shifts it right 2, because the horizontal shifts are always the opposite direction. So here my parent function is the square function, so it's y equals x squared, and since it's a plus 1, it shifts it left 1. So it's going to go left 1. Okay, so here we are going to graph. So we are going to identify the parent function, which is y equals the square root of x. This is down 1, and then this plus 2, it's our horizontal shift, and it's the opposite direction, so it's going to be left 2. So our shifts are down 1, left 2. Okay, so we're going to start off by drawing our base function. Our base function is y equals square root of x. So you need to either color code yours or use some sort of dotted system. So I'm going to do my parent function in red, and then I'm going to do my final function in black. So you can either do it dotted or have some sort of color coding. So the key points were 0, 0. If you plug in 1, you take the square root of 1, it goes through 1, 1. The next nice number I take the square root of is 4. When you take the square root of 4, it goes to 2. And then you can either do it dotted or have some sort of color coding. Okay, so that is the base function. I'm going to shift color so I can do my final graph, which is going to go down 1, left 2. So I'm going to take my 3 key points and shift them down 1, left 2. Shift it down 1, left 2. Down 1, left 2. So now I have my 3 key points. And I have my graph. I do expect to see your key points labeled, so for each of your dots you need to have the x and the y value marked. I don't need all of them. I don't need the end values. I need your dots, what those values are for your end graph. Okay, so your final result has to have the x and y values marked on it. That's what it means, graphing using key points. Okay, the next one, it is a cubic function. So our base function is the cubic, so it's y equals x cubed. And remember, if you look back at that original slide, the x cubed function looks like this, going through 0, 0, 1, 1, and minus 1, minus 1. So we're going to graph our base function. Okay, and it does have a curve. It kind of looks like an upward facing parabola on the right hand side in quadrant 1, and then this downward facing parabola side in quadrant 3. Our shifts are up 2 and then right 1. So now I'm going to take my 3 key points and shift them up to right 1. So I'm going to take my key points up 2, right 1, up 2, right 1, up 2, right 1, and then I'm going to connect with a smooth curve through my key points. I need to see my key points clearly marked, and then the values on the axes shown for those arrows on both ends, of course. Okay, so that is how we graph with shifts. So next what we're going to do is reflect. For reflections, if the negative is outside your function, like negative x squared, it reflects across the x-axis. Reflects across the x-axis if it's out front. And if it's inside your function, then it reflects across the y-axis. When we graph these, we're always going to graph our reflections and then our shifts. Okay, so remember that. Do reflections and then our shifts. Okay, so I have drawn in the base function, and then here, this is a negative inside, so when it's negative inside, it reflects on the y-axis. So I'm going to take my key points, and those were my key points, and I'm going to reflect it across the y-axis. 0, 0 stays the same. When I reflect this point, it goes over here. When I reflect this, it goes down to -4. So it's at -4, -1, 1, and 2. And this is the graph of h of x. Okay, so you do have to have some sort of color coding scheme so you know which is the final answer. Okay, so here we are going to identify the parent functions, the reflections, and the shifts. So here we're just combining multiple things. So the parent function is y equals square root of x. The shifts and reflections +1 is up 1. The +3 tells me it's left 3, and the negative out front tells me that it is a reflection on the x-axis. Okay, so I'm going to draw in the base function for the square root. So here's my base function. It goes through those key points. This is just square root of x. Okay, and then we're going to reflect it across the x-axis. That would be the next step. So when we reflect it across the x-axis, my points just reflect down, and this would be another function, y equals negative square root of x, and then we're going to do our shifts. So when we do our shifts, we shift our key points up 1 and left 3. So I have my origin, it goes up 1, left 3. This point goes up 1, left 3, up 1, left 3, and then it should have the same shape going in that direction, so it should look like that. And then I'm going to have my key points, -2, -3, 1, 1, -1. Okay, so there is our final answer. So now we have what is called the non-rigid transformation. So the non-rigid transformations are the shrinks and the stretches. So when we graph it, when we put it all together, we're going to do our shrinks and stretches, then reflections, then shifts. We do it in that order. Okay? So for shrinks and stretches, if you have a number out front that's bigger than 1, so a positive large number, then you multiply each y value by 3. Okay? But if the number is a fraction, we're still going to multiply each y value by 3, but in this case it's a shrink. So a bigger number stretches it. A fraction number will shrink it. It kind of squashes it down vertically. Okay, for a horizontal shrink and stretch, that's when you kind of pull it sideways. You take you're doing some sort of horizontal pull. And horizontal things like the shifts are opposite. So if you have a big number and horizontal is inside the function, then you multiply it by the reciprocal, the x value by the reciprocal versus the y value. And here you have a fraction between 0 and 1 inside the fraction. So here we're multiplying x by 1/2. So then we multiply each x coordinate by 2, because we're going to have a horizontal shrink and stretch. Okay, so I have in blue the base function y equals square of x, and then I did y equals 2 times the square root of x. So when it's inside your function, it's a horizontal. Because it's a 2, we multiply each x coordinate by the reciprocal, which is 1/2. So look at this y value here. The y value is 2 at this x value. So we are going to multiply it by 1/2 to give me there. So let's say this again. here's my x value of 4. We're going to multiply the x value by the reciprocal, which is 1/2. So 4 times 1/2 is 2. This value has an x value of 1. Multiply it by the reciprocal of that, which is 1/2. So it's graphed at 1/2. Same y value, but it gets kind of squashed. See, this blue one gets squashed so that these things get moved. Okay, so this 2 out front tells me that we are going to have a vertical stretch. This 2 tells me it's going to go right 2, and this 1 tells me it's going to go down 1. And that tells me if the parent function is y equals x squared. I'm going to switch my color so I can do it clearly. So it's y equals x squared. My shrink and stretch, it's a vertical stretch 2. And it's a vertical because it's outside the function. If it's inside the squaring function, it would be a horizontal. And shifts and reflections, they were down 1 and right 2. So we're going to go ahead and do those. So I'm going to graph my base function, which is the y equals x squared, and it had these 3 key points. And if you don't remember the key points, the easy ones to plug in are -1, 0, and 1, and then those are the y values. If I plugged in -2, I'd get 4 out. If I plugged in +2, I'd get 4 out. So I do know that it's going to go up there. You only have to do the 3 key points. Okay, but this just kind of gives me a guide. So that is my y equals x squared. Okay, so we're graphing our base function, and then we're going to do our shrink and our stretch. So when we do our shrink and our stretch, we're going to do a vertical stretch for 2. So when you have a vertical stretch, when your number outside your function is bigger than 1, it's a stretch, and you multiply each y value by that number. So I'm just going to multiply, this y value is 1, I'm going to multiply it by 2 because that's my stretch value, so it's going to go at 2. When I take this y value, which is 0, multiply by 2, I still get 0, so it's still going to go through this point. And when I take this y value, which is 1, it's going to go through here. So you can see that this green one, which is a U-shaped curve also, is y equals 2x squared. When in doubt, for this part, you need to graph y equals 2x squared. You can just make a table of values for x and y's, and you can plug in -1, 0, and 1, and see what values you get out. When you plug in it, you get 2, 0, and 2. And those are the things. Okay, so you would just take your base function key points and plug it into the graph with just the stretch. Okay, or the shrink for that matter would be the same. Okay, and then finally we're going to graph everything together. So now we're ready to do down 1 and right 2. So we're going to take our green ones and go down 1, right 2. The green one, down 1, right 2. And we have a similar U-shaped graph that goes through those points. And I'm going to mark those values on the axes. Okay, so that is my final answer. So please do dashes or color coding, labeling schemes, values on your axes. And that is how we graph. So remember, graph the base function, then the shrink and the stretch, then the reflection, and then your shifts. Okay, I hope you have a wonderful evening, my little lotus blossoms.